Hi guys, welcome to our today's class. My name is Galagash and I want to welcome you to our complete pure mathematics 1 for Cambridge AS and A-level international mathematics. And we are going to be covering the whole syllabus chapter by chapter, starting from the first chapter, which is quadratics. Here we ensure that every learner in Cambridge aspires, succeeds and progresses. So aspire, we help every student reach their full potential. Of course, we bring our esteemed academic standard to your classroom, and again we pack our resources with effective exam preparation, so you can trust Oxford resources to secure the best result. We embed critical thinking skills into our resources, encouraging students to think independently from an early age and building these foundations for future success. So basically we have 10 topic in this pure one, starting from quadratics. Then we have functions and transformations. We have coordinate geometry, line segments under coordinate geometry, and then topic 4, circular measures, where we look at radians, arc length and sector areas. We have trigonometry as topic number 5. We have binomial expansion, and we're going to focus more in Pascal triangle, which is a continuation in what you did in IGCSE. We have series. Under series, we are going to look at sequence. We are going to look at finite and infinite series, arithmetic and geometric progressions, and then we have differentiation. Now you guys are happy with that. Most of you are happy with that, popularly known as dy dx. At the end of this, I will be also leaving some of the exercise solutions below this video. You can check that out. So after differentiation, we will conclude this pure one with integration before proceeding to pure mathematics 2 for AS and A-level Cambridge mathematics. I want to believe you are ready for us to start this course. Let's consider this image. This is called a quadratic pavilion, which is part of the numerical art museum. It is part of the museum that is opened in 2001. And you can see this museum was constructed by Calatrava, and it received an outstanding award, an outstanding structure award in 2004. Designing such a shape and structure, constructing this need the use of quadratic curves and parabolas. Later on in this video, we will be looking at some concept in parabola, the equations of the ellipse, the equation of the hyperbola, and the function, their function in other objects. So let's proceed on quadratics. What is the objective of this course? Carry out the process of completing the square. Carry out the process of completing the square. So we are going to complete the square. So we will look at a quadratic polynomial in the form ax squared plus bx plus c. And then we will look at the discriminant, which is sharing the same equation, ax squared plus bx plus c. This is a discriminant of a quadratic polynomial, and we are going to introduce the formula for discriminant, b squared minus 4ac. So we are going to also look at how we can solve quadratic equations using any of the methods already mentioned, completing the square, factorization, using the quadratic formula, and so on, and more complex quadratic equations. And again, we are going to look at solving inequalities. By now you should be able to tell the difference between inequality and that of equation. An equation is a mathematical statement that supports the equality of two mathematical expressions. And we can look at the equations and an inequality. An inequality is a range number. It is a big number, so it is not equal. If I say that x plus y equal 2, it means that the solution is definite. It is equal to 2. This is different when you say x plus y is less than equal to 2. It means it can be 2, it can be something less than 2. So this, we are going to look at this concept. We are also going to solve simultaneous equations, linear simultaneous equation and one quadratic, and recognize and how to solve these equations is a main foundation that you need for excellent performance in your international exam in Cambridge. Conceptual understanding. Conceptual understanding. We are going to look at some of these entrance examinations in both Cambridge and Oxford. But what do you know? Conceptual understanding. So here we have root 3. You have the root 3 multiplied by root 3 to be equal to 3. Now you can ask me how. Well, it takes you back to the concept in IGCSE, right? The IGCSE, by laws of indices, we know conceptual understanding that root a multiplied by root a is nothing but a. Why that? It is because we know root a can be simplified as root a times a. And this is equal to root a squared. And when we take the square root of that, it will simply give us a. A squared will be what? A. So here we have root 3 multiplied by root 3. So this will give us root of 3 times 3. Right. So what is root of 3 times 3? Root 9. And root 9 is nothing but 3. So this is how we get 3. Conceptual understanding from what you did in IGCSE. And you can do the same. We have 2 root 5. This simply means that you can square 2 to get 4. 4 multiplied by 5 gives you 20. The roots cancels out. Again, you can look at factorizing quadratic expressions. IGCSE concept. You are able to factorize a quadratic concept in the form 2x squared minus 13x plus 20. And when we do that, we simply have 2x and x in separate bracket. And looking for the values that we can multiply to get 20, we get negative 5. And then we get negative 4. This is a simple expression. If it were to solve, you can as well go ahead and equate this to be 0, which is not within this question. Now you can solve linear inequality that is given. We have 5x minus 2 less than 8x plus 4. What is happening here? You can take 5 to this side and bring 4 to this side, right? So when you do that, you will simply have 8 minus 5 to give you 3x. And then we have negative 2, negative 4 gives you negative 6. Remember, when you divide anything by negative sign, the sign of inequality changes. So our x value is nothing but negative 6 divided by 3 gives you negative 2. So it is greater than negative 2. So this, again, you did in IGCSE. And we can solve two systems of equation. Like we have 2x plus 3y equal 5. And then we have 5x. This is equation 1. Pay attention. And this is equation 2. Right. So we have 5x plus 2y. And this gives you negative 4. Right. So you can use any of the method you know to solve this given equation. If we use any of the method we know, sorry about that. If we use any of the method we know to solve this equation, you can solve by elimination, you can solve by substitution. Elimination, substitution. And then you should be able to get your x values. If you want to eliminate one of these variables like x or y, we make sure that we have the values equal. And this again, you did in IGCSE. And we are going to look at some of this concept as we dive into quadratics. So quick check. Pause the video and try doing this yourself. What is root 7 multiplied by root 7? Again, it takes you back to what we did here, root 3 multiplied by root 3. Root 7 multiplied by root 7 should give you 7, right? We can see that. So you have root of 7, multiply this by root of 7. This is nothing but root 7 by 7. So you simply get the square root of 49. And what is the square root of 49? 7. Good. So this concept is what you already know in IGCSE. IGCSE. Use the same concept to solve, to test your understanding in question C and question D. I'll be leaving the answers in the link below this video. You can also test your understanding in factorization. You can solve by using the product and the sum. So you take the product and you can rearrange 6x squared minus x minus 1. So you can simply look for two values that you can multiply to get 6 multiplied by negative 1 gives you negative 6. And the sum must be equal to negative 1. Do that. Conceptual understanding. So this is what we did in IGCSE. Again, you can check your understanding in solving simultaneous equations. Quadratics. So welcome to quadratic equations. Solving quadratic equation by factorization. Let's look at the first example. By now you should be able to solve simple quadratic equation. So here we have 6x squared. 6x squared plus 11x minus 35 equals 0. Right, the first equation. By factorization, we can factor out 3x. And then we can have 2x. To get 35, we can multiply 7 by negative 5. So we have negative 5, positive 7. So then we equate this to be 0, right? We equate this to be 0. Such that what is going to happen, we have 3x minus 5. So this is equal 0. This implies that we have 3x is equal to positive 5 when we take 5 to that side. So x is simply 5 over 3. Again, we can have 2x plus 7 equals 0. Implies that we have 2x equal negative 7. So that we divide both sides by x, 2, we get x equal negative 7 over 2. So this again is very simple. IGCSE, you simply take this value that we have to this side, it becomes negative 7. Let's look at what happens in B. you have 20x squared plus 80 is equal to 82x. First of all, this is not a standard equation. So we can try to rearrange to make this in a standard form. So we are going to have 20x squared. Taking 82 to that side become negative 82x plus 40. This is equal to 0. These are big numbers and they are divisible by 2. So if we divide 20 by 2, we can get 10x squared minus 82 divided by 2. That gives us 41x plus 20. When you divide 80, you get this is supposed to be 80. Then we get 40, and this equals 0. Now we can go ahead and factorize this. We can have this is a factor, this is 10 and 40, so we can have 5x, and then we can have 2x. 5x and 2x, such that we have 8 by 5 gives us 40, so this is negative 8 and then negative 5. So this is equal to 0. Solving for x, we have 5x minus 8. This is equal to 0. Implies that 5x is equal to 8. Divide both sides by 5. So x is equal to 8 over 5. Alright. Again, we can solve up here. We have 2x minus 5 equals 0. Implies that 2x is equal to positive 5. Divide both sides by 2 so that x is equals to 5 over 2. So this is another concept you did in IGCSE. Let's proceed to the next question. A rectangle has length x plus 1, x plus 3 meters, and width 2x plus 1 meters. So we have the length and the width. You are required to find the length of the rectangle. Well, for us to do that, let's consider the area of this rectangle, right? The area of this rectangle is given by the equation. The equation is 2x plus 1. 2x plus 1, right? Multiply this by the length, and the length is given by x plus 3. X plus 3. Again, this you did in IGCSE. Expand this. You did expansion, binomial expansion. When we expand this, we are going to get 2x squared. 2x squared, and then plus 7x. 7x plus 3. And this is equal to 12 meters as indicated. Now you have a quadratic equation. Now rearrange this to be in the standard form. We have 2x squared plus 7x. Take away 12 from 3, you have negative 9. And this is equal to 0. Right, now we can factor out. We simply have 2x. And then we are going to have the value x. So how do we get 9? We can have plus 9 and then minus 1. So this is equal to 0. Such that we can solve to find the value of x. So 2x plus 9 equals 0. Implies that we can have 2x equal negative 9. So x is simply what? X is negative 9 over 2. Again, we have x equal to 1 because x minus 1 equals 0. And when you take, when we take the value that we have, which is negative 1 to the other side, it becomes positive. So x is equal to 1. So the answer to this question is either x is negative 9 over 2 or x is equal to 1. Conceptual understanding from your knowledge in IGCSE. Let's proceed to the next question. Here we have exercises. I have left these exercises for you to try your understanding and check the answer in the link below the video. At least do question A, B, C, D. If you have time, you can try all the questions. And you can see we have even done similar question of the length and the width. So you find the area and then you are able to write your equation in a standard form and find the value of x in the given equation. Solving quadratic inequalities 1.2. Okay, to solve a quadratic inequality, it is useful to sketch the curve. It helps you to visualize and see exactly what you are doing. If the coefficient of x squared is positive, the curve opens upward. This shape you can see. And if it opens downward, it means it is negative. So let's look at example number 3. Solve the inequality x squared minus 3x minus 4 greater than or equal to 0. Again, you can just illustrate. There is a sketch that you should look at. Maybe we have a sketch of this graph, -1 here, -1 up to positive 4. In this case, this is 4, y-axis, x-axis. So you have a shape that is this way. Don't mind my drawing. So you will note that there are only 2 regions. So we write the answer as 2 inequalities. We write the answer as 2 inequalities. Because you have x squared, we have x squared minus 3x minus 4 greater than or equal to 0, implies that we have x plus 1, right? And then we have x minus 4, x minus 4. So this is greater than or equal to 0. When you solve these two, it's simply x plus 1. Let's say they are equal to 0, meaning that x is equal to -1, right? So if x is equal to -1, we also have the second one, which is x minus 4 equals 0, meaning that x is equal to +4. So we can write this as a sign of inequality. So the answer to this inequality is x less than equal to -1 that we got here, because when we use negative, the sign of inequality changes, or x is greater than or equal to +4. So this again is what we did earlier in year 11 IGCSE. Let's look at number 4. Solve the inequality 6 plus x minus x squared greater than 0. So here we go. We have 6 plus x minus x squared greater than 0. You can rewrite this as x squared, right? So we have x squared minus x. So we have minus x minus 6. Then the sign of inequality changes to less than 0, such that we can factor out this. We have x minus 3 and then x plus 2, x plus 2. So this is less than 0. If you solve, you will simply have solved x minus 3 equals 0, meaning that x is simply positive 3. X plus 2 equals 0 means that x is simply what? Negative 2. So the answer to this question is negative 2 less than x less than positive 3 that we got here. Very simple. Let's proceed to the next question. Solve the inequality x plus 5 and 2x. So we have x plus 5, 2x plus 1 less than equal to 0. So test your understanding. Let's do that together now. So we have from question 5, we have x plus 5 and then 2x plus 1. This is less than equal to 0. When you solve for x plus 5 equals 0, implies that x is negative 5. And when we solve for 2x plus 1 equals 0, this becomes 2x equal negative 1. So x is negative a half. So what you will observe is that the answer to this question is negative 5. Negative 5 is less than equal to x, less than equal to half. Correct. So this is as simple as that. I have left you some exercises for 1.2. Check it out and confirm with your answer on the link below the video. The method of completing the square. The method of completing the square. Well, we can express quadratic polynomials in the form ax squared plus bx plus c, in the form a into x plus p squared, where p and q are going to be a constant number. So it is a into x plus p squared plus q. So here we have two values for p and q. So p and q are constant. So we need to follow this method and this particular concept strictly as we use it to find the value of x in our quadratics equations. Let's see by example. Look at example 7. 2x squared minus 12x plus 1 in the form a into x plus p squared plus q. This is a method of completing the square. Again, you identify what is p and half it, then square it. So let's look at this that we have 2x squared minus 12x plus 1 can be written as 2 into, we are going to have x squared minus 6x plus 1, because we know 2 by negative 6 will give us negative 12. When you complete the square, it will simply be dividing b, when our b in this case is 6. Divide 6 by 2, you will get 3, and the square root of 3 is 9. So by the method of completing the square, we are going to have 2 into x minus 3. Then square this, minus 9 plus 1, such that we are going to have 2 into x minus 3, x minus 3 squared minus 18 plus 1. So the answer will be what? We have 2 into x minus 3 square this, minus 18 plus 1 is negative 17. So we cannot divide 2x squared minus 12x plus 1 by 2, as it is not an equation. If we had 2x squared minus 12x plus 1 equals 0, we could have, as that will be an equation. So this is the method of completing the square. Look at, you can try to check the answers as indicated here. This is something the same I have already solved. 2 into x minus 3 squared minus 17. So let's look at the next example. Example 8. So we have 3 plus 4 plus 4x minus x squared. And you are supposed to use the method of completing the square. So again, this, we can take the negative outside and we simply have x squared minus 4x minus 3. Right. Such that we are going to have, by completing the square, we can have b, meaning that 4 divided by 2 will give us, we have our negative 2, so we have x minus 2 squared. Then minus 4, 2 squared is 4, minus 3. So we are going to get 7 minus x minus 2 squared as your final answer. You simply multiply the terms in the square bracket by -1 to get that. So a quadratic equation of the form ax squared plus bx plus c, where a, b, c are constant, it is good to note that c is not equal to 0. It can as well be solved by the method of completing the square. Okay, number 8. We already solved number 8, so just confirm and try to follow through. Question 9. Solve the equation x squared minus 6x plus 2. X squared minus, so you have x squared minus 6x plus 2 equals 0. Alright. You are supposed to give your answer in the form x equal p plus or minus the root of q. Okay, so again we have x squared minus 6x. If we take the half of 6, if we take the half of 6 is 3, right? So we are going to have x minus 3, then square it, right? Minus 7. Square of 3 will give you 9, so it's 9, then plus 2. This is equal to 0. So we are going to have x minus 3 squared minus 7. Because negative 9, take out, add 2, give you positive 7. and it was equal to 0, so we have to solve. This means that x minus 3 will be equal to plus or minus the square root of 7. And taking 3 to that side implies that x is nothing but positive 3 plus or minus the square root of 7. So do not forget that plus or minus when taking the square root of each side is very important. So the answer is either x is 3 plus root 7 or x is 3 minus root 7 in the form required, p plus or minus the root of q, and this is the required solution. Let's consider example 11. Solve the inequality, and our inequality in this case, we have 3x squared plus 24x plus 2 is less than 0. So you're supposed to solve by completing the square, and you leave your answer in short form. Okay. First, let's consider 3x squared plus 24x plus 2 to be equal to 0. So let's take this as an equation. If 3x squared plus 24x plus 2 is equal to 0, we can solve. As we are considering an equation, we can ensure the coefficient of x squared is 1 by dividing each term by 3. If we divide each term by 3, 3 divided by 3 gives you 1, so we have x squared. And we can divide 24x by 3, so we have plus 8x. Right. If we divide 2 by 3, we will have plus 2 over 3. So this is equal to 0. And now we can try to simplify 8x and x. So we can have x plus 4. If we factorize this method of factorization squared, this will be equal to we can have the value negative 46. Now we have 8. This gives us 16 plus 2 over 3 equals 0. 16 plus 2 over 3 equals 0. Such that x minus 4 squared is going to be equal to, take negative 16 and 2 over 3 to that side, we are going to get, this is minus 46 over 3. 46 over 3, and this must be equal to 0. So x plus 4 squared is nothing but positive 46 over 3. Positive 46 over 3. Solving for x plus 4 squared. For x plus 4, since it's a square root, we are going to have plus or minus the root of 46 over 3. The root of 46 over 3. Now consider that this is an equation. But if we solve and take 4 to the other side, we will simply have x is equals to negative 4 plus or minus the root of 46 over 3. but we considered that 3x squared plus 24x plus 2 was not an equation. It is an inequality less than 0. So the answer becomes -4 negative the root of 46 over 3 is less than x less than -4 plus the root of 46 over 3. And that is what is required in this equation. Now there are exercises here. Test, try for your understanding, and check the answer in the link provided. Let's look at solving equation using the formula. Solving the equation by the formula method. A quadratic equation can be expressed in the form. A quadratic equation can be expressed in the form ax squared, right? So it is ax squared plus bx plus c equals 0, right? A and B and C are constant. So the three values A, B, C are constant, K. So we can use the method of completing the square to find the general formula for solving the quadratic equation. And the process of getting the formula is indicated. Again, we have ax squared plus bx plus c, right? So this is equal to 0, isn't it? So we can have x squared dividing both sides by a plus b over ax plus c over a. This is equal to 0. So to square both sides, because we have x squared, so we can have x plus b over 2a squared minus b over 2a. Square this. This must be equal to c over a to the other side. Or simply add it up first. If we add, we will have minus plus c over a, right? And this is equal to 0. So you will see that we have x plus b over 2a squared, which is equal to b squared over 4a minus c over a. Simplifying this will give us x plus b over a plus or minus the square root of b squared minus 4ac, which by simplification gives us minus b plus or minus the square root of b squared minus 4ac, all this divided by 2a. And this is the quadratic formula that is required for us to find or solve quadratic equations that requires us to use quadratic formula. So let's use this formula and solve the given equation. Solve the equation 3x squared plus x minus 5 equals 0. So we have 3x squared plus x minus 5 equals 0, right? So we want to solve using the quadratic formula. First of all, you identify what is A, B, and C. This is A, B, and C. So our A is 3, B is 1, right? And our C is -5. Now we substitute the given values in the equation. We are going to have our x is equals to -b, so it is -1. Our b is 1, -1 plus or minus the square root of b squared, meaning it is the square root of 1 squared, minus 4ac. Our a is 3, c is -5. Then divide all this by 2a, and our a is 3. 2 times 3. When you solve this, you'll see that we have x -1 plus the root of 61. Divide this by 6. Or our x is going to be -1 negative the root of 61 divided by 6. And you can leave your answer this way, or maybe in fractions, in decimals. In decimals we have 1.135042 as the value of x, or -1.468375. Continue. So it is useful to write bracket when substituting the values to ensure we do not make errors with negative values. And this is how you use the quadratic formula. Conceptual understanding. Try to solve question 13 using the quadratic formula. You get your answer as x less than equal to 3 minus, this is x less than equal to -3, -√11. Or maybe our value is x greater than equal to -3 plus the root of 11. And you can check the link below the video for steps. So we have various exercises here that help you to solve various equations using the quadratic formula. Solving more complex quadratic equations. Now there is a hint on how you can solve this more complex quadratic equation. Try to adapt the equation to quadratic form. So if you adapt the quadratic equation in the form, we are going to have the values. Equation is given x power 4 minus 5x squared plus 4 equals 0. Let's take a black pen. So now we are going to have, if we have this to be equal to 0, let's let y to be equal to x squared, right? Hence our equation becomes y squared minus 5y plus 4 equals 0. So when we have this, we can substitute y for x squared. but we have y minus 4, because this is y squared. So y minus 4 and y minus 1. This is equal 0 by factorization. So when you solve, you will see that y is equals to positive 4 or y is equals to positive 1. What will be our x squared? Our x squared is equal to 4 or our x squared is equal to 1. So the x value is nothing but plus or minus 2, the square. Since this is x squared, so it is plus or minus 2, or x is nothing but plus or minus 1. Right. So factorize straight away in order for us to find the value. So we have x squared minus 4. We have x squared minus 4, and then we have x squared minus 1. So this is equal to 0. So x squared is equal to 4 or x squared is equal to 1. Of course, this is plus or minus 4 plus or minus 1. So our x is nothing but plus or minus 2, or our x is plus or minus 1, what we got earlier here. And you can see this. Try to follow through. This might be well arranged than the one I did earlier. Look at question number 16. Solve the equation 5x power 4 minus 20x squared minus 1 equals 0 by completing the square. Again, we already did completing the square method. You can do this and try to confirm the answer from the link below the video. And this is the exercises for your homework. Try and check your progress on the link below the video. The discriminant of a quadratic equation. Discriminant. When you look at the discriminant, observe what happens. Because sometimes we call the solutions of the quadratic equation the roots of the equation. It tells us that the quadratic graph crosses the x-axis, or maybe the quadratic graph crosses the y-axis. Earlier on in this video, I mentioned the formula that we use, or we are going to be using, for the discriminant, b squared minus 4ac, which is from the quadratic formula in the form negative b plus the root of b squared minus 4ac divided by 2a. There are conditions that must be satisfied when looking at discriminant. So we have the first condition. There are two distinct real roots if b squared minus 4ac is greater than 0. So if the discriminant is greater than 0, there are two real roots. There are two real values of x. If the discriminant is equal to 0, there are equal roots, one repeated root. And if the discriminant is less than 0, then there are no real roots. And we are going to consider these graphs in terms of the discriminant. and we are going to look at this concept from our next video as we look at the discriminant of quadratic equations. We are going to solve some equations relating to discriminants, and we look at simultaneous equations, and finally how to graph a quadratic equations, and we will be done with quadratics, which is the chapter 1, before we proceed to chapter 2, functions and transformations. See you in our next video. Galagash.